This video is going to introduce you to imaginary numbers or the complex numbers. Before we begin in the notes, I do want to take note of what complex numbers are. So in our numbers, the complex numbers, which we denote with this capital C, include the real numbers, and the real numbers are what you probably have learned about in your other classes. So we're expanding on real numbers to include the complex number system. And why we need this is sometimes in the real world, we need to be able to solve for the square root of a negative number. Now, square roots as a function cannot have negative inputs. So normally on the real numbers, we don't take the square root of negatives. We say that x must be greater than or equal to 0. But there's a whole new and different place on our number spectrum called the complex numbers in which we can do so. So we're going to call the square root of negative numbers the imaginary component, and we call that I. Now, if you square both sides of that equation, notice that the property of I squared is -1. Let's look at a couple examples of this in practice. So if I needed to find the square root of +49, I should be able to note that 49 is a perfect square of 7 times 7. So I could say that the square root of 49 is the same as 7 squared. Square roots and squaring are inverse operations, and so these would essentially cancel and I would get 7. However, this example has a negative on the inside, so let's talk about how this is just a smidge bit different. I'm going to rewrite -49 as -1 times 7 times 7. The square root of -1 gives me I, and then the square root of 7 squared gives me 7. I'm then going to write this as 7I. Here is another example. Find the square root of -50. Well, the square root of 50 is not, or 50 I should say, is not a perfect square. I might say like, oh, well, it's 5 times 10, but that doesn't really help me because 5 and 10 are not multiples, like it's not a multiplicity of 2 of the same number, like 7 and 7. And so I might be like, that doesn't help me, but maybe I expand this a little bit further and say, oh, but 10 is 5 times 2. Well, then on the inside, I could write that 50 is 5 times 5 times 2. Now I have 5 2 times. Another way to write this would be 5 squared times 2. Now, the 5 is squared. That would cancel with my square root and take the 5 out. However, 2 needs to stay inside my radical. All right, now let's apply the fact that this is -50. The only thing that changes is that I would have a -1 on the inside. The square root of -1 is I. the square root of 5 squared is 5. And the square root of 2, I cannot take my 2 out of my radical. And then the form in which we write this is 5i, just like we wrote 7i right here, and then times the square root of 2. What we do not write is 5 root 2 and then the I on the right-hand side. The reason in our notation we do not write it this way is sometimes we get a little sloppy with our radical and where it needs to end, and sometimes we might get confused with where I really belongs. So it's best to write your imaginary number with the part on the outside of the radical, and then write the radical and then whatever's left on the inside piece.